All right, I want to go over a few things about pulleys, and I think this problem is going to be good for it. One thing I want to point out, and I mentioned this before, is that pulleys, with a pulley, we're assuming it's a frictionless pulley. And so in statics, right, all the pulley is doing is redirecting the tension of that's supplied by a rope or a cable. And remember, you can't put a cable or a rope into compression, right? It's only tension. So you see it represented by this T. The force is the tension, and that's T. Also for these problems, I'm going to use Y. Upward is the positive direction. So let's just look at a few of these, and we're going to draw some free body diagrams. We have a 600-pound crate suspended by different rope and pulley arrangements. So it wants to determine the tension in the rope. So the first one here, I'm going to draw the pulley because that's what we're doing the balance on. The pulley's not moving. It's in equilibrium, and it's got 600 pounds acting down, and it's got tension acting up through the rope, which is running through it like this, right? So you've got a pulley that looks like this. It's got one rope hooked to the ceiling, and then one rope is under some kind of tension. I don't know if that's someone pulling on it or something else. So we can write an equation where the sum of the forces in the y direction equals 0, right? Because this is not moving. So remember we talked about if the forces, or if something's not moving, the sum of the forces must be equal to 0. It's balanced. So this can lead us to write 2 times t in the positive y direction minus 600 pounds equals 0, right? These are the sum of the forces. 2t, or t plus t, minus 600 pounds in the opposite direction. So here we find t is equal to 600 divided by 2. So t equals 300 pounds. Why don't you pause the video and maybe sketch out what you think letter B is going to look like? All right, assuming you pause this, I'll sketch this out for you. So I've got a pulley here, and I've got 600 pounds acting downward. What do I have balancing this pulley out? Well, I've got one rope here and one rope here. It doesn't matter where this rope attaches to. I've still got a tension in it, T, 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 right? So I'm gonna perform the simplest balance I can, which means I'm gonna cut the rope right here. I'm isolating this pulley. I want to perform a balance on this pulley. The pulley is being acted on by 600 pounds downward and tension upward. So this is the same as part A. So you wind up with 2t minus 600 pounds. So t equals 300 pounds again. All right, I'm going to do part C, and let's look at this first. All right, what's going on in C? Well, now you've got this pulley and a box, and the way this is attached to the rest of the world is you've got 600 pounds down, and you've got 1, 2, 3 ropes, right? This one connects to the middle of the pulley. It connects to like where the, I guess the pin is. So we're going to draw this like this. You got 600 pounds. And we write our balance. Sum of the forces in the y is 0. Oops. So this means we've got what? We've got 3t, right? So t plus t plus t minus 600 pounds equals 0. So this leads us to t equals 200 pounds. So you can see reconfiguring this such that the rope, you've got basically a third rope. So this didn't give us any advantage over A, right? But you can see you get the advantage if you tie it to the center of the pulley, right? Now you've got 1, 2, 3 points on that center location, so you get mechanical advantage. So why don't you guys pause this video, jot down D and E, and see if you can't solve those, and then come back and I'll go through them. Okay, assuming you've jotted those down, drawn some free body diagrams, and then solved the problems for D and E. Let me just go through the solutions I have here. I'm going to show you D first. I tried to draw this. I tried to draw the whole contraption first. And so D has this bottom pulley that's got the crate on it. I probably should have drawn the crate in. And it's got this top pulley that's connected to this smaller pulley. And the rope goes around 1, 2, 3. So we've got the way this is connected to the rest of the world is it's got the load, right? And the best way to do this is to cut it like right here, right? And so then we'll have a pulley that looks like this. 600 pounds down, and 1, 2, 3, 3 lines of tension supporting it vertically. So the sum of the forces here is going to be 3T minus 600 pounds. That's an LB. And you wind up with the tension is 200 pounds. So you can see this again this is similar to case C. This is basically the same setup as case C. Adding the pulley, the way it was added here didn't give you much, well, didn't give you any mechanical advantage. So now let's go to part E. All right, so E you had a pulley that looked like this. You got the 600-pound box, bottom pulley. Now in this case, you've got a small pulley attached to the bottom large pulley, and you've got the rope going through the pulley system this way, right? So how would you disconnect this from the rest of the world? Well, there's a few ways to do this, but the way that kind of makes the most sense is to cut it right here. So you've got tension in the rope that is continuous, right? All these have T, 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 and T. So you'd wind up with a diagram, a free body diagram that looks like this. Tension off the top one, tension on the bottom one. These two pulleys are connected, right? So this is essentially a rigid single body. This is like one point you're doing the balance on. So you can write the problem this way. Sum of the forces in Y is 0. You have 4T minus 600. You wind up with a tension of 150 pounds. There is another way to draw this. I alluded to it earlier. If you just want to focus on this pulley down here and you cut it right here, well, you've got to make the realization that this is 2T. So you could draw it like this. So these two are equivalent for this system. A lot of times you don't do something like this because you're kind of splitting the rigid body. Because these are connected together, they're sort of considered as one. But this is a legitimate way of doing it as well. I've seen people do that where they just lump it in. This takes a little more practice, and this is something that someone more knowledgeable in statics would do, right? Someone who's been doing the problems longer. They just make the realization, oh yeah, this is 2T. Yeah, so there's pulleys for you. Thanks for watching.